autocorrelation function and its properties. You all know about autocorrelation function, which is used to provide the similarities between two observations of a random process. Okay, two observations of a random process. That means in a random process x of t, if you compare the properties at two time instants like t1 and t2, then it is called autocorrelation function. Right? Consider a random process x of t for different times t1 and t2. Then the autocorrelation function is defined as r suffix defined as r suffix double x of t1 comma t2. Okay, this is the formula for this is the formula for autocorrelation function r suffix double x of t1 comma t2, or we can take tr t plus tau here. That means there are two time instants, right? Is equal to expectation of x of t1 into x of t2. Expectation of x of t1 into x of t2. And also the formula for this is, you consider two time instants of a random process, then we consider double integral x of t1 into x of t2 f suffix x1 x2 colon t1 t2. This is joint density function of a random process. This is a random process at time t1, and also this is a random process at time t2. dx1 dx2 right, which is the formula for autocorrelation function. This is the formula for autocorrelation function. Here we can substitute in place of x1 t and t plus tau here, then it becomes r suffix tau is equal to expectation of x of t into x of t plus tau. X of t into x of t plus tau, where tau is a delay function, where tau is a delay function. Right? This is the simple definition of autocorrelation function. In previous papers also is asking about define autocorrelation function, explain the properties of autocorrelation function. Right? Explain the properties of autocorrelation function. Is equal to r suffix double x of tau equal to e of x of t into x of t plus tau. This is the basic formula. Now we will go through the properties of autocorrelation function, which is equal to, the first one is here, the first property is the mean square value of x of t is, what is not the mean square? E of x square is nothing but the mean square value of the random process x, right? Here it is E of x square of t, which is nothing but mean square value of a random process x of t. Mean square value of a random process x of t, which is equal to E of x square of t. It is equal to r suffix double x of 0. R suffix double x of 0, right? That means this is the property. We have to prove this property. R suffix double x of 0 means here in place of tau, we, we will get 0 here. We will get 0 here for E of x square of t. E of x square of t is equal to R suffix double x of 0, right? This is also nothing but the power of a random process. E of x square of t is also nothing but the power of a random process. There are some problems related to this topic, like mean square value of this topic. We will see later. Now the proof is also a simple one. This is the formula for autocorrelation function. R suffix double x of tau equal to E of x of t into x of t plus 2. Right. This is the formula for autocorrelation function. Now substitute tau is equal to 0 here. Substitute tau is equal to 0 here. Then R suffix double x of tau becomes R suffix double x of 0, and E of x of t into x of t. It is nothing but E of x square of t, right? That means if you substitute the time shift value 0, then it is equal to the power of the random process. E of x square of t is nothing but the power value of a random process. Okay. This is about the first property. This is about the first property. The second one is autocorrelation function is maximum at origin. That means at 0, the autocorrelation function has a maximum value, that is modulus of R of tau is less than or equal to R suffix double x of 0. That means at 0, the autocorrelation function value is maximum. Okay. Here consider a positive value x of t1 plus or minus x of t2 is greater than whole square is greater than equal to 0. Greater than equal to 0. If you expand this, take a positive quantity here of x of t1 and x of t2. These two are sample functions of a random process x of t. If you expand this, after this is in the form f plus the whole square, then it is equal to x square of t1 plus x square of t2 plus or minus 2 into x of t1 into x of t2. Right? This is the formula for this function. Now apply expectation on both sides. Then we put E of x square of t1 plus E of x square of t2 plus or minus 2 into E of x of t1 into x of t2 is greater than or equal to 0. What is the value of x square of t1? E of x square of t1 is equal to 0, right? This is E of x square of t1 is nothing but 0 here. X square of t1 is equal to 0. Then substitute 0 here, which is nothing but R of 0 plus R suffix double x of 0 plus or minus 2 into, this is the formula for autocorrelation function R suffix double x of tau, that is equal to 0. Then 2 into R suffix double x of 0 plus or minus 2 into R suffix double x of tau, that is equal to 0. Now solve this, you can get this equation. is the proof for the second property, which is autocorrelation function is maximum at origin. Then modulus of R of tau is less than or equal to R suffix double x of 0. Okay, this is the second property of a autocorrelation function. And the third one is R of tau is an even function of tau. Autocorrelation function is an even function. Also remember, autocorrelation function is an even function. Even function means like sin of minus x equal to sin x. See, sorry, cos of minus x equal to cos x. That is where the cos function is a even function. In other words, sin of minus x equal to minus sin x, right? Where sin x is an odd function. Cos x is an even function and sin x is an odd function here. Right? Likewise, here autocorrelation function is an even function. For that, we have to prove r of minus tau equal to r of tau. R of minus tau equal to r of tau. Here also suffix r double x of minus tau equal to r double x of tau. Okay. This is also a simple proof for this. This is the formula for autocorrelation function. Here tau is equal to substitute tau is equal to minus tau. That means in place of tau, you have to substitute minus tau. Substitute minus tau, then this equation becomes like this. Like e of x of t into x of t minus tau. X of t minus tau. Now substitute u is equal to t minus tau. That implies u is equal to t minus tau. That implies t is equal to u plus tau here. T is equal to u plus tau here. See nothing but x of u. That means in place of t, in place of t, we have to substitute u plus tau here. And also in place of u, sorry, in place of t minus tau, we have to substitute u here, right? Then this equation becomes like this, which is equal to e of x of u into x of u plus tau here, which is also a autocorrelation function with time with delay function r of tau. Then r of minus tau equal to r of tau, which is an even function of tau, right? It is an even function of tau. R of minus tau equal to r of tau, which is an even function of tau. These are the this is the property for an autocorrelation function. Similarly, these are the general properties like if a random process x of t has non-zero mean and ergodic with no periodic components, then limit t tends to infinity r of tau equal to e of x of t whole square. These are about ergodic or ergodicity. We will discuss about ergodicity in the next topic. And other one is if a random process x of t is ergodic with zero mean and no periodic components, then limit tau tends to infinity r of tau is equal to 0. What is the main difference? Here is a non-zero mean and ergodic process. Here is a zero mean with ergodic process and no periodic components. Then this is the formula limit tau tends to infinity r of tau is equal to 0, which here limit tau tends to infinity r of tau is equal to e of x of t whole square. E of x of t whole square. All of you observe the difference between these properties. E of x of t whole square here, E of x of t whole square here for limit tau tends to infinity. Here which is E of x square of t. This is the mean square value, which is equal to r of 0. And for this property, which is E of x of t whole square for non-zero mean. Right? The autocorrelation function does not have any arbitrary shape. This is the other property. That means autocorrelation function does not have an shape. It varies accordingly with the time functions of a random process x of t. Right? These six are the major properties and most important properties of autocorrelation function. Important properties of autocorrelation function. Right? Here is the problem. We already mentioned about this problem. This is asked in a previous paper, right? This was asked in previous paper. The autocorrelation function of an ergodic process with no periodic components is given by ergodic process with no periodic components is given by r of tau is equal to this function. Find the mean and variance of the random process, right? Find the mean and variance of the random process. Right? This was the same problem I already mentioned in the last classes. Given that the autocorrelation function for a stationary ergodic process with no periodic components, is r of tau equal to R of tau equal to 25 plus 4 by 1 plus 6 tau square. Find the mean and variance of a random process x of t. Find the mean and variance of a random process x of t. Right? Right? This is the problem. The autocorrelation function of a random process of a ergodic process with no periodic components is given by R of tau is equal to 36 plus 1 by 4 plus 5 tau square. Find the mean and variance. Right? Now, coming to the solution of this problem. Coming to the solution of this problem. R of tau is equal to 36 plus 1 by 4 plus 5 tau square. Here is the ergodic process with no periodic components. Right? Just now we are discussing about these properties. Just now we are discussing about the property. This is the property. Coming to fourth property, which is if a random process x of t has non-zero mean and ergodic process with no periodic components, then limit tau tends to infinity, R of tau equal to E of x of t whole square. Right? E of x of t whole square. Limit tau tends to infinity, R of tau equal to E of x of t whole square. Right? This is the formula E of x of t whole square here. So E of x of t. What he has given limit x tau tends to infinity. Sorry, tau tends to infinity. Then if apply infinity to this term, which is equal to infinity, then 1 by infinity, which is equal to 0. And finally we get 36 here. Finally we get 36 here, which is the mean square value, E of x of the whole square. Then also we have to find mean and variance, right? From this mean value is E of x of t whole square is equal to 6, then E of x of t is nothing but 6 here. That means mean value is equal to 6. Then coming to E of x square of t, E of x square of t, this is the first property we are discussed just now. The mean square value of x of t, the mean square value of x of t is E of x square of t. If we want to find out the E of x square of t, then it is equal to R sub x double x of 0, right? R sub x double x of 0. That means if we substitute tau in place 0 in place of tau, then we will get mean square value of random process x of mean square value of random process x of x square of t is equal to 36 plus 1 by 4 plus 5 tau. So to substitute 0 in place of tau, then we will get 36.25. The formula for variance is E of x square minus E of x square minus E of x whole square. That means E of x square of t minus E of x of t whole square, which is nothing but the variance of a random process x of t. These two are important formulas which are discussed in the properties of the autocorrelation function. Properties of autocorrelation function. He is also asking about mean and variance of a process. Except mean and variance of a random process. Except here. Right? This is about properties, autocorrelation function and properties of autocorrelation function and the problem related to autocorrelation function. Problem related to autocorrelation function. Okay. All of you just take a look on these properties. Look at the first property. Please, all of you, properties, any doubts, ask me about the first property because in exams you definitely asking about the properties of autocorrelation function and cross correlation function. Okay, all of you, please look at this first property and any doubts, please ask. The first property is the mean square value of a random process. Mean square value of a random process is equal to the R sub x double x sub, which is also nothing but power of a random process. E of x square of t is equal to R sub x double x sub 0. Is also nothing but the power of a random process. Right? This is about the first property. Now, please look at this. Any doubts, please ask me. Okay. Please remember this formula about the mean square value. And coming to next property, which is autocorrelation function is maximum at origin. That means origin means tau is equal to 0, which is the maximum value. R of tau modulus of R of tau is less than equal to R of 0. He has given some proof regarding this property. He assumed some equation and applied this equation. We finally prove this property. We proved about this second property also. Third one is autocorrelation function is an even function of tau. Autocorrelation function is an even function of tau. It is R of minus tau is equal to R of tau. Okay. R of minus tau is equal to R of tau. This is about the third property. And the fourth one is if a random process x of t has non-zero mean and ergodic with no periodic component, then R of tau is equal to T of x of t whole square. This is very important property and a very important formula. Problems are likely to be asked about this property also. Next, cross correlation function and properties. This is the formula. This is also a problem related to the same problem, but the values are different. Here, he has given the autocorrelation function of a random process with no periodic components is given by 49 R of tau is equal to 49 plus 5 by 1 plus 7 tau square. Find the mean and variance. This is also a similar formula. Substitute tau equal to infinity. Then we get some 49 here. And based on this, if we find out the mean value, which is nothing but a square root of 49, this is 7. Also, E of x square of t. If we want to find out the variance, we need to calculate E of x square of t is equal to 49 plus 5 by 1 plus tau of 0, which is nothing but the 54. 14 plus of 54, so find the variance. We will get the variance value, which is 5. Variance is equal to 5 here. Variance value is 5. All of you please practice the two problems discussed in this class regarding autocorrelation function and ergodic functions. Both are similar problems. And this model is important for this is also the same. This is also the same problem. Okay. I shared the material for 4th and 5th units. Please practice the problems related to autocorrelation function of this model. Right? Any doubts?